Our bodies require oxygen to survive, and this oxygen is delivered by the blood to the organs and tissues. Oxygen enters the blood from the lungs and is taken up by haemoglobin in the red blood cells. Each molecule of haemoglobin can hold 4 oxygen molecules. Haemoglobin carries the oxygen while it is being transported. Haemoglobin is a protein that is made up of 4 heme groups which contain ions. These ions associated with the haemoglobin molecules chemically react with oxygen to form oxyhemoglobin. Some people suffer illnesses which affect the quality or amount of haemoglobin in their bodies. This can cause serious problems with transporting oxygen to their organs and tissues. When oxyhemoglobin reaches a tissue in need of oxygen, the oxygen is released from the haemoglobin protein through dissociation due to lower local O2. The red blood cells will now return to the lungs and oxygen will once again bind to the haemoglobin proteins. Haemoglobin and oxygen reacts to form oxyhemoglobin. This is a form of dynamic equilibrium. The chemical equation for this reaction is Hb aqueous plus 4O2 gaseous equilibrium HbO2 4 aqueous. In 1840, the haemoglobin protein that carries oxygen was discovered by Hernfeld. In 1851, in his articles about diluting red blood cells with a solvent such as pure water or alcohol, Otto Funk explained growing haemoglobin crystals. Circa 1862, Felix Hopseiler discovered the binding of oxygen to erythrocytes as one of the haemoglobin's functions. After studying haemoglobin in crystalline form, he discovered that haemoglobin contains iron. In 1959, using X-ray crystallography, Max Perutz established the molecular structure of haemoglobin, applying Le Chatelier's principle to the reaction. Pressure affects equilibrium at both high and low altitudes, as air pressure directly correlates with the amount of oxygen needed in order to survive. According to Le Chatelier's principle, a decrease in pressure will cause the system to react oppositely. This will favour the backwards reaction and cause a shift to the left, where the gas moles are more. Concentration of O2-4 and Hb will increase, and the concentration of HbO2-4 will decrease. KEQ is affected and decreases. Low air pressure results in less oxyhemoglobin needed for survival and more hemoglobin and oxygen to be present. According to Le Chatelier's principle, an increase in pressure will cause the system to react oppositely, favouring the forwards reaction. This will result in a shift to the right. O2-4 decreases, Hb decreases, and HbO2-4 increases. KEQ will increase. Concentration of oxygen. In the lungs, the concentration of oxygen increases. According to Le Chatelier's principle, the system will react oppositely, favouring the forwards reaction, which is a shift to the right. Concentration of O2-4 and Hb decrease, and concentration of HbO2-4 increases. KEQ will increase in order to produce more oxyhemoglobin. In the tissue, the concentration of oxygen decreases. According to Le Chatelier's principle, the system will react oppositely, favouring the backwards reaction, and the system will shift to the left. Concentration of O2-4 and Hb increases, and HbO2-4 decreases, causing the KEQ to decrease. A high increase or decrease in temperature will cause protein denaturation for oxyhemoglobin, which results in an increase within the concentration of hemoglobin and oxygen. According to Le Chatelier's principle, the system will react oppositely. The forward reaction is favoured and a shift occurs in the system to the right. Concentration of O2-4 and Hb decrease, and concentration of HbO2-4 increases, causing the KEQ to increase. In order to maintain hemoglobin equilibrium, the production of oxygen masks within planes had to occur. Therefore, it controls safety regulations for divers and flyers. Usually on planes, when the pressure of oxygen drops in the cabin, oxygen masks will drop. Hemoglobin equilibrium is critical in understanding the effect of hypoxia on the human body. Hypoxia is due to the property of pressure being disrupted in the system that causes a sudden decrease of oxygen that cannot be reimbursed. This results in death due to the lack of oxygen transport. This system impacts the medical community due to the health-related risks that can be associated with damaging the hemoglobin. Individuals who are born and raised in high altitudes will have their bodies re-establish equilibrium shift by producing more hemoglobin, which allows for more oxygen to be bound to the heme protein and thus causes an equilibrium shift to the right. What would we do without the hemoglobin equilibrium? Without this buffer, no oxygen would be transported throughout the body, meaning cells would not be able to function, ultimately causing death. This equilibrium not only restores oxygenated hemoglobin, but also transports oxygen to oxygen-deficient areas in our body.